Myself, Neha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you from the subject Signal and System. The topics are causal and non-causal system, static and dynamic system, and the stable and unstable system from the unit of Introduction to Signals and System. So today we will cover the example based on these three types of this system. So we are starting with the first system, which one is causal system. Now first of all we will defining the causal system. What is causal system? A system is a causal system if its output depends only on the present and past value of the input and does not depend on the future value of the input, then it will consider as causal. And if it will be depending on the future value of the input, then it will consider as the non-causal system. So if we are defining the non-causal system, a system is non-causal system if its output depends on the future value of the input, then it is considered as non-causal system. So we are solving the example based on these two types of system. Now the next type of the system is the static system. Static system means any system output at any instant of time depends on input sample at the same time, then it is known as static system. Static system means if the system output depends only on the present value of the input, then it is considered as static, and as it is not depending on the past and the future value of the input, so there is no requirement of the memory element. So this kind of system is also considered as memoryless system. Now the next type of system is dynamic system. Now what is dynamic system? Any system output can depend on the present as well as on past or the future value of the input, then it is considered as the dynamic system, and as there will be memory requirement is there, so it will consider as with memory system. So if we are defining the dynamic system, it will be defining as if the system output depends on the input sample at the same time as well as on the other instant of time, then it is known as the dynamic system. Now the next type of the system is a stable system. Now what is stable system? If we are taking the input as a finite number and output will also the finite number, then it will consider as stable and it will be considered as BIBO stable. Now what is the meaning of BIBO? BIBO means bounded input, bounded output. It means bounded means it will be considered as finite. So for every finite input, the output will be finite, then it will be considered as bounded input, bounded output, stable system. Otherwise, it will be considered as unstable system, as for the finite input, the output will be infinite, so it will be considered as for bounded input, the output will be unbounded, then it will be considered as bounded input, bounded output, unstable system. So if we are defining the stable system, a system is said to be BIBO stable system if it produces a bounded output for every bounded signal applied at its input. And if we are defining the unstable system, it will be defining as a system is said to be BIBO unstable system if it produces an unbounded output for every bounded signal applied at the input. So it means if we are applying the finite input, then the output will be infinite, so it will be considered as unstable system. And if we are applying the finite input and it will give you the finite output, then it will consider as bounded input, bounded output, stable system. Now we are solving some example based on these three kinds of the system. The first example is determine the following system is causal or non-causal, static or dynamic, stable or unstable. For that the system is given to like this, y of t equals to x of t by 2. Now if you want to solve this example, so for that first of all we will finding whether the given system is causal or not. So what is the definition of causal system? If the system output depends on the present or past value. So how it will be considered as past value? Suppose if I am taking the present value as 2 seconds, so on the 2 second comparing to 2 second, the 0 second will be considered as past, 1 second will consider as past, and if we are taking the 3 seconds, it will consider as future value. So based on this, we are solving these examples. So starting with this y of t equals to x of t by 2, we are taking different values of time, and if we are putting the different values of t, then From that we can define whether the given system is causal or not. So in this we will taking the value of t equals to -1, 0 and 1. So starting with t equals to 0, if we put in t equals to 0 in this equation, so the value of y of 0 is equals to x of 0 by 2, and 0 by 2 means 0. So y of 0 equals to x of 0. Now you can see that x of 0 means input at 0 second and y of 0 means output at a 0 second. So from this you can say that the output will be defined on the same time. So this will be considered as the present input. Now if we put in the value of t equals to 1, then the value of y of 1 is equals to x of 1 by 2. X of 1 by 2 means 0.5. Similarly, if we are taking t equals to -1, then the value will be y of -1 equals to x of -1 by 2. So -1 by 2 means x of -0.5. So from this we can say that this one is present input, 0 input, at the same time 0 output. So it will consider as the present input. Now if we comparing this, then on 1 second, before 1 second, 0.5 second will be there, right? So for that, this will be considered as the past input. And if we consider this, then comparing to -1, -0.5 is considered as the future input. And as it will be depending on this future input, so it will be considered as non-causal system. And if we want to find out whether the given system is static or dynamic, so for that, the definition is like that. The output will be depending only on the present value of the input. And you can see that here the present, past as well as future value will be affecting to the output, right? So for that, we can say that as this system will depending on present, past or future value, so this system is considered as a dynamic system. Now if you want to solve that whether the given system is stable or unstable, so for that we have to take the input signal as the finite, and for the finite input signal, output signal should be finite, right? So for that we are taking the input signal x of t as the finite number. So finite means its amplitude will be finite. Now if we are taking x of t by 2, x of t by 2 means it is considered as one kind of timing operation, right? So it will gives you the expansion in the input signal. So it will give you the expansion in the time only, it will not giving the expansion in the amplitude. So it will give you the finite values of the input, right? So as the input x of t is finite, so the value of x of t by 2 will also finite. And as y of t equals to x of t by 2, so it will be finite, so y of t is also considered as finite. So as we have taken input signal x of t is finite and we have derived y of t equals to finite, so we can say that this system is bounded input, bounded output, stable system. Now the next example is determine the following system is causal or non-causal, static or dynamic, stable or unstable. For that the system is given to be like this, y of 1 is equals to 2 into x of 2 raised to n. Now if you want to solve this example, starting with causality, so we will taking the equation as y of 1 is equals to 2 into x of 2 raised to n. Now in this, if you want to find out whether the given system is causal or not, so for that we are taking the different values of n, like n equals to -1, 0 and 1. So always we are taking any negative value, any one positive value or 0 value. So we are taking these three values and depending on that we will deciding whether the given system is causal or not, static or dynamic. Right, so for that we are taking the value of n equals to 0, so the value of y of 0 equals to 2 into x of 2 raised to 0. Now 2 raised to 0 means 1, so we are taking y of 0 equals to 2 into x of 1. Now similarly we are taking n equals to 1, so for that n equals to 1, the value of y of 1 is equals to 2 into x of 2 raised to 1. Now 2 raised to 1 means 2, so it will give you the term as 2 into x of 2. Now we are taking the third value as n equals to -1, so for that we are putting n equals to -1, so the term will be y of -1 is equals to 2 into x of 2 raised to -1. And 2 raised to -1 means 1 by 2, so it will give you the term as 0.5. Right, so we are taking this value as 2 into x of 1 by 2, or we can say that 2 into x of 0.5. Now we can see that compared to 0, 1 will be considered as future input. Compared to 1, 2 will be considered as future input. Compared to -1, 1 by 2 will be considered as the future input. So as this all the values will be gives you the future input, so this system is considered as non-causal system because the system output depends on the future input. So it will be considered as non-causal and it is also considered as dynamic. Now if you want to solve the same example for the stable or unstable system, so for that we will taking the input signal as finite, so for that the output should also be finite. Otherwise it will be considered as unstable system, right? So in starting with input signal x of n as finite number, so the value of x of 2 raised to n will be finite. Because in x of something, it will gives you the change in the x axis. It will not change in the y axis. So the amplitude will remain as it is. So if we are taking x of n as finite, so it will gives you the x of 2 raised to n will also finite number. So y of n is equals to 2 into x of 2 raised to n, so it will be also considered as finite because the finite number will be multiplied with 2. So it will give you the finite number, right? So for finite input, the output will also finite. So we can say that the system is bounded input, bounded output, stable system. Similarly, if you want to solve the next example, like determine the following system is causal or non-causal, static or dynamic, stable or unstable. So for that y of t equals to x of t plus x of t minus 2 is given to you. So if you want to solve this example, so starting with the causality, we will taking this term as y of t equals to x of t plus x of t minus 2. Right. Now in this, we will putting the different values of t starting with t equals to 0. So what will be the value of y of 0? Y of 0 equals to x of 0 plus x of 0 minus 2. Instead of t, we will take in 0 in the above equation. So this equation will be there. Now if you simplify this, then it will give you the term as y of 0 equals to x of 0 plus x of minus 2. Similarly, we will find in for t equals to 1. So in this equation, we will taking t equals to 1. So the term will be y of 1 equals to x of 1 plus x of 1 minus 2. After simplification of this term, it will gives you the output as x of 1 plus x of minus 1. Now the next term is t equals to minus 1. So if we put in the t equals to minus 1 in the above equation, so the term will be y of minus 1 is equals to x of minus 1 plus x of minus 1 minus 2. So the term will be x of minus 1 plus x of minus. Now you can compare this three terms as if we are taking output on 0 seconds, so it will gives you the input on 0 as well as on minus 2. So 0 means present value and minus 2 will consider as the past value, right? Now if we are comparing this term, so for 1 second, 1 will consider as present value and minus 1 will consider as the past value. Now if we are considering y of minus 1, so x of minus 1 will consider as the present input and x of minus 3 will consider as the past input. Right. So as this all the terms will be depending on the present and past value of the input, so this system is considered as the causal system. Now as it will be depending on present as well as past value, so to store the past value we will require the memory element. And as it will be depending on the past value also, so it will consider as the dynamic system because it will be depending on the present as well as on the past values, it will consider as the dynamic system. Now if you want to solve the same example for the stability, so for that first of all we will taking the input signal x of t as a finite value. So for that the value of x of t minus 2 is also finite because x of t minus 2 is considered as the time shifting property, right? So time shifting, in the time shifting the amplitude will remain as it is, just the signal will be shift toward right side. So the value of x of t minus 2 is also finite. Now if we are finding the value of y of t, then the value of y of t equals to x of t plus x of t minus 2. So x of t is finite, x of t minus 2 is finite. So summation of these two finite numbers will give you the finite number at the output side, right? So as we have taken the input signal x of t as finite, so for that the value of y of t is also finite. So we can say that for finite input, output is also finite. So this type of system is considered as bounded input, bounded output, stable system. Now the next example is determine the following system is causal or non-causal, static or dynamic, stable or unstable. For that the value of y of n is equals to n into x of n. Here the discrete time system is given to you. We will solve the example similar to the continuous time signal. So if we solve in this example, first of all we will solve for the Causal system. So for that we will taking y of n is equals to n into x of n. In this equation we will taking the value of n equals to 0. So if we will put in the value of n equals to 0, so the term will be y of 0 equals to 0 into x of 0. Now if we are taking the value of n equals to 1, then the term will be y of 1 is equals to 1 into x of 1. Now if we are taking the value of n equals to minus 1 in this equation, so the term will be y of minus 1 is equals to minus 1 into x of minus 1. Now we can see that y of 0 equals to 0 into x of 0. It means output at 0 second will depending on the input at the 0 second. It will consider as a present input. Similarly, if we are taking y of 1 equals to 1 into x of 1, it means output at the 1 second will gives you the output when the input on the 1 second is taken. So it will also consider as a present input. Similarly, for input at minus 1 will gives you the output at minus 1, it means it will also consider as a present input. As all the output will depending only on the present input, so from this we can say that any of the input is depending only on the present input, so it will be considered as Causal as well as the static system, because it will be depending only on present, it will not depending on past or the future value of the input. Now we have to solve the same example for the stability, right? So for that we will taking the input signal as finite, it means we will taking the x of n as a finite number. So if I am taking the input signal x of n as finite number, so the value of x of n is finite. Now if I am taking n tends to infinite, means if I am taking n equals to infinite, then the value of n into x of n will becomes infinite into an infinite number means infinite, right? So the value of y of n means output will gives you the infinite number. So as we have taken input as a finite number, but output may be infinite number if we are taking the value of n is infinite. So from this we can say that this system is BIBO unstable system, because we have taken the input signal as finite number but output will be infinite. So this way we can solve any example for causality, means whether the given system is causal or non-causal, static or dynamic. It is also considered as memoryless or memory with memory system, or stability. It means it is whether the given system is bounded input, bounded output, stable system, or it is unstable system. In the next session, we will starting with the new unit. Thank you so much.